Okay, I'm going to be doing cards number 13 and 15 from 4.2, Systems of Equations. This is asking us to graph the system of equations and identify its point of intersection. This first equation is always or already in mx plus b form. Before we graph it, is nice to have the equation in the form y equals mx plus b. Looking at the second equation, it's not in mx plus b form. I'm going to go ahead and change it so that it is. So here, I'm going to try to isolate the y. So first I'm going to subtract 3x from both sides. Then if I divide this by -1, I need to divide the whole equation by -1, and that becomes y equals positive 3x plus 2. So I have this equation and my first equation. I'm going to graph them both on the same axis and see if I can figure out where they intersect. Okay, so my first equation has a y-intercept of 9. And a slope of -4. So -4, so down 4 over 1. Down 4 over 1, so this is my first line. Okay, now the second equation has a y-intercept of 2, so I'm going to start at positive 2, and a slope of positive 3. So up 3 over 1, up 3 over 1. So you can already see here that these two lines are intersecting, and the point of intersection is right here at 1, 5. So that is the solution to this system. Moving on to card number 15, we have another system of equations here. This one is already in mx plus b form. I'm going to go ahead and change this one. So if we move the 2x over to the other side and then divide everything by 2. Okay, notice that we ended up with the exact same equation as the second one here. So if we were to graph this, y-intercept of positive 4 and a slope of -1. And then if we graphed this equation, well, it's the exact same equation, so it's like you're graphing another line right on top of this one. That means the lines are intersecting at all points, and so this would be considered infinite solutions.